This is number 9, Intro to Calculus practice test. If you want to do number 1 and you don't have a graphing calculator, then you can get this graph that I have right here on Desmos. So let me show you. Here's my Desmos screen, and I just typed the function in on the left and I was able to graph it. So that'll help you with that. All right, let me go back. So the answer to this one is A. And all of these are increasing from negative infinity. And if you start at negative infinity, there's no increasing. There's only this decrease. So that one's pretty easy. You know A is going to be your only choice. Remember when we increase, it's over the domain. So we're going to go from 0 to 2. We're increasing, which is right, right here. And then from 2 to 4, we start down here and we increase from 2 to 4. And then we're decreasing from negative infinity to 0, and we're decreasing from 4 to infinity. Here I can show you with a pen. So the increase is here, and then the increase, you start down here and you increase. And then the decrease is going to be here from negative infinity to 0. And then the decrease is going to be here, which is this maximum point 4 to infinity. So here's the decrease, and here's the increase. All right, number 2, we're going to find the reference angle. And so in order to find the reference angle, since this is negative, we're going to go in a clockwise direction. All the way around is 360. If you take 480, subtract 360, you get another 120. So you'll go 90 and then go 30 more. So that angle there is 30. So in order to find the reference angle, you're going to bring this up to the x-axis, and the reference angle is right here. And so the reference angle is 60. So B. 60 degrees. Number 3, find the reference angle. So this is in radians. What I like to do is take 9 and divide it into 23. 9 goes into 23 twice, which is 18, remainder 5. And so I'm going to rewrite this number as negative 2 and 5/9 pi. So when I graph negative 2 and 5/9 pi, the negative is going to make us go clockwise, and 2 pi is the full circle. Then when we think of 5/9 pi, 5/9 is a little bit bigger than a half. And so a half pi is going to be this 90-degree angle. So how this works is we go 1 pi over 9, 2 pi over 9, 3 pi over 9, 4 pi over 9, and then 5 pi over 9 is going to be here. And so reference angle is when we draw a perpendicular line to the x-axis, and we're looking for this angle right here. So if you think about it, let me highlight, from here to here is, 5/9 pi. So what would then 5/9, it would be 6/9, 7/9, 8/9, 9/9 is the half circle. So what would that angle there be? That angle right there is going to be 4/9. Another way to find that is you could take pi, you could subtract 5/9 pi, and that's going to give you this remainder of what's left. So the common denominator is 9, and 9 pi over 9 subtract 5 pi over 9 is equal to 4 pi over 9. So from here to here is 5 pi over 9, and the reference angle, which is from here to here, is 4 pi over 9. And when we add those together, we get 9 pi over 9, which is simply pi, which is this half circle. So our answer is C. Number 4, we're supposed to find the period. To find the period of a trig function, it's 2 pi over b. In this case, b is 3. And so if we do 2 pi over 3, that will be the period. So the answer is B. Number 5, find the phase shift in radians. So the phase shift is going to be your left or right, and it's what's in these parentheses, but you have to factor the b out first. So this will be y equals 10 sine, and then factor out 6. So you'll factor that 6 out. And then this is going to be pi over 36. And how you know you have that right is if you were to take 6 and multiply it to this, you would have 6 pi over 36, which reduces to pi over 6, which is what you started with. So when you factor this out, you actually multiply it to the denominator. And then you have plus 2. And so phase shift is opposite of what you think. So theta plus pi over 36 is going to be opposite of what you think, left pi over 36. So the answer is D. Number 6, what we're going to do to solve for this trig equation is we're going to isolate the cosine theta. So the first thing we'll do is subtract the 2. And this is 2 over 1, so we're going to get a common denominator of 5. So that gives me 11/5 minus 10/5 is 1/5, which equals 2/5 times cosine theta. Then we're going to get rid of the 2/5 by multiplying both sides by the reciprocal. 5/2. 5/2 times 1/5 is equal to 1/2. So 1/2 equals cosine theta. So you're going to ask yourself, where is theta equal to 1/2? So it's the inverse cosine of 1/2. So cosine's positive in the first quadrant, it's equal to 1/2 at pi over 3. And in the fourth quadrant, it's equal at 5 pi over 3. So our answer is B. Number 7, we're supposed to find the sine of theta and the cotangent of theta if the cosecant of theta is -4. So since cosecant is going to prom with sine theta, all you do is they're reciprocals of each other. So sine theta is -1/4. Looking here, if I look down the choices, there's only one choice that has sine theta as -1/4. So you can pick A with confidence and move on. If you want to figure out cotangent, then what you would need to do is you would need to draw sine theta. This is opposite over hypotenuse. And we know we're going to be in the third or the fourth quadrant because the sine is negative, but the cotangent is greater than 0, which is positive. So now we know for sure that we're in the fourth quadrant. And I know this isn't the best picture, but here's my triangle. And sine is opposite, so that's -1, and over hypotenuse, which is 4. So now you're going to use Pythagorean to find the other side of the triangle. So here I did a squared plus b squared equals c squared, and b is the square root of 15. And then to find the cotangent, we know tangent is OA, so you're going to flip that. So it's root 15 over 1. So the cotangent of theta, let's see where I can write that up here. The cotangent of theta is equal to, oh, by the way, this is left, so you can put the sign on there because it should come out positive. So it's going to be root 15 over 1, which is just the square root of 15, and that was that part. On number 8, don't be tempted to use SOHCAHTOA because this is not a right triangle. You have to use law of sines or law of cosines. I have a side angle side, and so I'm going to use the law of cosines, side angle side. Here's the law of cosines, so I can go ahead and plug everything in. So I'll call this side A is going to equal the square root of, and then I'll take b squared, which is 14 squared, plus c squared, which is 10 squared, subtract 2 times 14 times 10, cosine of that angle, 95 degrees. Plug that all into your calculator and let's see what we get. If you tried this and you were like, oh my gosh, my answer's not there, I got 9.568, that means your calculator was in radians mode instead of degree mode. So you have to make sure you're in degree mode and you'll get 17.9, which is B. Number 9, find angle A. This is side, side, side. So we're going to use the law of cosines again, which is up here. I like to find angle A. I like to use this formula, which is the inverse cosine. Whoops. Let me fix that. The inverse cosine. And then you do b squared plus c squared, subtract, and if you're looking for angle A, then it's always subtract a squared over 2bc. So let's go ahead and find angle A, which is this angle right here. So we have angle A is equal to the inverse cosine, 15 squared plus 21 squared, subtract 29 squared over 2 times 15 times 21. Calculator, make sure you do second cosine to get inverse cosine. Make sure you're in degree mode, and you're going to get 106. Number 10, find the direction angle for each vector. Here's what this vector is going to look like. You go left 15 for the horizontal component and up 47. When they ask for the directional angle, we are looking for this angle starting here at standard position and going in this direction. So we are looking for that angle right there. So if we look at the process of elimination, we know that we are in the second quadrant, which means we can cross out A, we can cross out C. 162 is in the second, so we'll keep that and we'll keep D. So it's going to be B or D. So what you're going to do is draw yourself a right triangle, and that has an arrow on the end. Let me fix that. All right, so we're going to drop a line down to the x-axis. We're going to form a right triangle, which is right here. We're going to find what theta prime is, and then after we find theta prime, we can find the directional angle. So looking at the right triangle, the height of this vector is this vertical component of 47, and the length of that triangle is going to be negative 15. So you can see in order to find this angle, we're just going to use inverse tangent. So we will say the tangent of theta is equal to opposite over adjacent, and you don't have to worry about the negative. Theta is going to equal the inverse tangent of 47 over 15. On your calculator, you're going to put in second tan, make sure you're in degree mode, And theta is going to equal 72.700. So that is theta prime, which is right here. But we want the directional angle, which is this purple angle. So in order to find the directional angle, if we take 180 degrees, which is the full half circle. So if we take 180 and we subtract theta prime, that's going to give us theta. So 180 subtract 72 is 107.700, which is D. Number 11, find the magnitude for each vector. So we have the magnitude of vector CD, where C is 7, 9, and D is 4, negative 9. So I plotted the point C, 7, 9, and the point D, 4, negative 9. And remember, a vector has direction. So we are going to start at C and go end at D. And we want to find the length of that vector. The magnitude of this vector is simply the length of the vector. So this is the distance formula. The only thing you have to be careful of is x1, y1 is always your start point, and x2, y2 is always your end point, because vectors have a direction. So you have to make sure you label those properly. So if you apply the distance formula, then x2 is 4, so it's going to be 4 subtract 7 squared, plus, and then negative 9 subtract 9 squared. So go ahead and figure out what that is, and that's going to be our magnitude. So 4 subtract 7 is negative 3 squared, plus negative 18 squared. That's going to be the square root of 9 plus, let me do 18 squared, 324. This is going to equal the square root of 324 plus 9, which is 333. And I don't see my answer here, so I am assuming there's a perfect square that comes out of that. And I'm getting approximately 18.248, which is D. So this is 3 root 37. 9 times 37 is 333. So in this problem it says find negative 2 times vector F, subtract 8 times vector V. And then once we do that, we're going to find the magnitude of that result and the directional angle of that result. So let's go ahead and do that first. So we're going to take negative 2 and multiply it by vector F, which is 5, negative 3. And this is component form, these brackets. And then we're going to subtract 8 and then multiply it by vector V, which is 0, 5. So take the scalar and multiply it first. So negative 2 times 5 is negative 10. And negative 2 times negative 3 is 6. Subtract, and then 8 times 0 is 0. And 8 times 5 is 40. Okay, now we're going to go ahead and subtract those two vectors. So negative 10 subtract 0, you subtract the horizontal component, which is negative 10, and then you subtract the vertical component. So 6 subtract 40 is negative 34. I'm going to graph this really fast. So this is the result vector. This is what this looks like. Basically, you go left 10 and down 34. So if I want to find the magnitude of this, I need to find the length of this vector. So basically what we're doing is we're drawing a right triangle So there's my right triangle. We know that I went left 10 and I went down 34. So if I'm trying to find this side of the triangle, then it's just a squared plus b squared equals c squared. So this is Pythagorean to find the magnitude, which is just the length of that pink vector. So when I find the length of this, which is the magnitude, it's the square root of a squared plus b squared. And that's going to be the square root of 1256. That's going to give me, it's almost easier just to do the decimal since they have the answers in the decimals here. But that's 2 square root of 314, because 4 times 314 gives me 1256. So here we have 35.44, which is C. I can pick the answer and not have to find the direction angle because these are all different. Now, if I want to find the direction angle, that's going to be this angle starting here and coming all the way around to there. How to find that directional angle is you can use inverse tan and do opposite over adjacent. Figure out what that angle is, and then you can take 180 plus that angle for the directional angle, which is going to be 253.61 degrees. All right, looking at number 13, find the measure of the angle between the two vectors. Let me write the formula. So the first thing we're going to do on number 13 to find the angle between these two vectors is we're going to do u dot v. So just a reminder about what u dot v is. That would be if u is 8, -4, dot v, which is -4, -2. Dot product means we're going to get a scalar or just a number. So it's first times first, which is -32, plus -4 times 2 is 8, and that's going to give us -24. Then we're going to do the magnitude of u. The magnitude of u is simply the square root of 8 squared plus -4 squared, which is the square root of 64 plus 16. And 64 plus 16 is 80. So this is the square root of 80. Then we're going to find the magnitude of v, which is going to be the square root of -4 squared plus -2 squared. That's going to give me 16 plus 4, which is the square root of 20. So now we're actually able to use this formula to figure out what the angle is between these two vectors. And I'm kind of out of room. Let's see. Let me see if I can scroll down a little bit. All right. So back to this. We're going to do the angle is equal to the inverse cosine of u dot v. Sorry, there's some stuff down there. And u dot v was -24 over the square root of 80 times the square root of 20. And I know there's perfect squares in both of these, but I really don't care because I'm just going to throw it all into my calculator to figure out what this angle is. So in your calculator, make sure you're in degrees mode. You'll do second cosine, and then you're going to do u dot v on the bottom. You'll divide that into a -24, and you're going to get 126.869, which is going to be 0.870. And then you hope you did it right. You come up here, you look for your answer, and there it is. Ta-da! And that's 1 through 13. I'm going to post these and then do the second half.